Have you ever wondered why pressure transmitters are so crucial to the oil and gas industry? Well, they're vital for safety, efficiency, and productivity, playing a key role in controlling and monitoring operations. But not all pressure transmitters are created equal. In fact, there are several different types, each with its own unique characteristics and working principles. First up, we have the strain gauge pressure transmitters. These handy devices measure pressure by converting it into an electrical signal. They do this through a strain gauge, which deforms or strains under pressure. This deformation changes the electrical resistance of the gauge, which can then be measured and used to calculate the pressure. Then there's the capacitive pressure transmitter. This device operates on a slightly different principle. It contains a diaphragm and a set of electrodes, forming a sort of mini capacitor. When pressure changes, the diaphragm moves, altering the distance between it and the electrodes. This change in distance changes the capacitance, which can be measured and used to determine the pressure. Next, we find the piezoelectric pressure transmitter. This one's a bit different. It uses a piezoelectric crystal, which generates a voltage when subjected to pressure. The voltage is then measured and used to calculate the pressure. Finally, we have the resonant pressure transmitters. These utilize a resonating element, typically a quartz crystal. When pressure is applied, the frequency of the resonance changes. This change in frequency is then measured and used to determine the pressure. Each of these pressure transmitters has its own strengths and weaknesses. Strain gauge transmitters, for example, are simple, reliable, and cost-effective, making them a popular choice for many applications. However, they can be less accurate than some other types, particularly at very high or very low pressures. Capacitive transmitters, on the other hand, offer excellent accuracy and stability. They're also less susceptible to temperature changes than strain gauge transmitters. However, they can be more complex and expensive. Piezoelectric transmitters are highly sensitive and can measure very rapid changes in pressure, yet they are not as stable over time and can drift, requiring regular calibration. Resonant transmitters are incredibly accurate and stable even over long periods, but they are more complex and expensive than other types. In summary, the choice of pressure transmitter in the oil and gas industry depends on the specific requirements of the application. Strain gauge transmitters might be the go-to for simple, cost-effective pressure measurement. Capacitive transmitters could be chosen for their accuracy and stability. Piezoelectric transmitters might be the pick for measuring rapid pressure changes, and resonant transmitters for their long-term accuracy and stability. So, next time you hear about pressure transmitters, you'll know there's more to them than meets the eye. They're not just about measuring pressure, they're about doing it in the most effective, efficient, and accurate way possible for the task at hand. And that, in a nutshell, is why they're so crucial to the oil and gas industry.